So hello students. So today we'll be seeing about Unit 5. So we have come to the fourth part of Unit 5. So today we'll be seeing about supervisory control and data acquisition. So we call it as SCADA. So here you will be learning about supervisory control and data acquisition. So already you know some basics about SCADA. So here in this topic we'll be learning in detail about supervisory control and data acquisition. So first you have to understand the concept of SCADA. So SCADA stands for Supervisory Control and Data Acquisition. So it is a control system that uses computers, network data, communications and graphical human machine interfaces. So that we call it as HMI to manage and control industrial processes. So this is considered to be a sophisticated control architecture which is designed to oversee and manage industrial operations. So it also integrates with computers and along with the network communication systems and graphical human machine interfaces. It is used to monitor, visualize, and control complex processes in real systems. So these systems, when you consider, they serve as a central nervous system of industrial environments. So it also interfaces with field devices like programmable logic controllers, proportional integrated derivatives that we call it as PID controllers and so on. So through this connectivity, SCADA enables operators to supervise the equipments, and it can also adjust parameters and it can ensure optimal performance across manufacturing plants. So SCADA is nothing but it's a system which can communicate with other devices with the help of programmable logic controllers and PID controllers to interact with the industrial process plants and equipments. So these systems are crucial in control systems engineering. So usually this SCADA systems they collect and analyze real-time data from processes. They record and log this data and it tries to display on the various graphical interfaces. So the system enables process to control operators to supervise. So we have so many things which can be enabled here. So it also enables operators to control these processes by interacting with the HMI. So S is nothing but it represents SCADA, and C represents is nothing but the control operation. So we'll in basics we'll be learning about generic SCADA systems. So in supervisory control and data acquisition systems, they are really essential to for a wide range of industries, and they are broadly used for controlling and monitoring processes. So when you use these type of systems, they are prominently used for control, monitor, and transmit data in smart and seamless way. So when you consider these type of systems in today's environment, data-driven world, we are always looking for ways to increase automation. So this always makes us to understand the concept of smarter decision making through the proper use of data, and we are using SCADA systems where we can achieve all these control operations. So when you consider SCADA systems, it can be operated remotely. So this can help allowing operators to monitor and control process from anywhere, right? So SCADA can be used efficiently to save time. So here we have some examples. So when we use SCADA systems, which are extensively used in oil and gas sector, so we'll be using large pipeline transport for transporting oil and chemicals inside the manufacturing unit. So hence safety plays a crucial role here. So there should be no leakage along the pipeline. So if any leakage is occurred, SCADA systems is used to identify the leakage So it infers the information. So after inferring the information, it transmits to the system and it displays the information on the computer screen and it gives the operator an alert. So here we can consider this example. So next moving on to SCADA architecture. So generic SCADA systems contains both hardware and software components, and here we'll be learning about the SCADA architecture. So this hardware and software, it is used to monitor and control industrial operations. So when you consider software, the software is installed on a central computer. Okay, so it handles all the data analysis and visualization, where the hardware interfaces with the sensors and field devices are used to collect real-time input from the physical process. So after collecting all the information, so the data is gathered by the hardware and it is transmitted to the SCADA systems. So after transmitting the data, it is stored on a hard disk for logging, and historical analysis can also be performed. So operators can retrieve and print this data as needed for reporting and for diagnosis purposes. So when you consider based on the implementation, to implement the control logic, especially for programmable logic controllers, SCADA systems are used basically with basically with the structured text. So it's considered as a high-level programming language, which will be supporting complex and flexible automation strategies. So, SCADA technology is widely adopted across industries such as energy and oil and gas. It is also used in power generation, water treatment, waste management, and they are critical to operational efficiency and safety. So, basically considering the SCADA's history, so the SCADA systems, when you consider manufacturing flows and industrial plants, it relies on manual control and monitoring. So it uses push buttons and analog equipments. So when you consider the size of the industries and manufacturing units grow, so they start using relays and timers so that we can provide supervisory control to a certain extent. So unfortunately, we can consider relays and timers that can solve problems only with minimal automation functionality. So here we can perform reconfiguring the system. So reconfiguring the system is a little bit difficult, but we can go for more efficient and fully automated system, which is required by all industries. So these type of industrial control purposes was developed in 1950s. So after that, they have introduced the concept of telemetry, where we can use virtual communication and data transmission. So when you see after later 1970s, uh, the SCADA was coined along with the evolution of microprocessors and PLC concepts. So this helped to develop fully automated systems that can be used remotely in the industry. So by in early 2000s, modern SCADA systems have come into existence, and it has allowed us to control and monitor real-time data anywhere in the world. Okay, so the thing is, you have to understand the concept of real-time interaction. So this real-time interaction has bloomed up the business, and it has took the growth of industries to greater heights. So even if the operator did not have much knowledge of software development, we will be able to manage modern SCADA systems. So now we'll be learning about objectives of SCADA. So when you see the objectives of SCADA, it considers about six different points. So it is based on monitor, measure, data acquisition, data communication, controlling, and automation. So when you consider monitoring, so here we can consider continuously tracking physical parameters so across industrial processes to ensure operational visibility and responsiveness. So that is the first objective. And moving on to the second objective, it is measure. So measurement is based on the capture and you can quantify process variables for accurate analysis and control. So next moving on to data acquisition. So it acquires data. So collection of real-time data from field devices such as remote terminal units, sensors and data loggers can be used here. So next we have data communication. So it facilitates high volume, reliable and data exchange between master terminal units and RTUs. So this enables centralized oversight. So next is controlling. So this supports real-time supervision and dynamic control of industrial operations, which enhances safety and efficiency. So moving on to the final objective, so it's automation. So it helps for automatic transmission. So it enables automatic execution of task and process adjustments. So which can considerably reduce manual intervention and it can also improve consistency. So next we'll see about SCADA systems architecture overview. So when you consider SCADA systems, they are composed both of hardware and software components. So I told you earlier, so it is used to monitor and control industrial processes. So the SCADA applications typically run on a central server, so which is handled by data processing, visualization, and control logic. So when you consider human machine interfaces, so it usually uses desktop computers with graphical displays. So it can be connected to the server, allowing operators to interact with the system in real time. So there are some primary components of a SCADA systems, so which includes master terminal unit that is called as MTU. So it acts as a central controller, coordinating data flow, and it can use command execution across the system. So that's about master terminal unit. And next we'll be learning about a remote terminal unit. So that is RTU. So here it interfaces with field equipment to collect sensor data and it can execute control commands. So next moving on to communication network. So it provides infrastructure for reliable data exchange between MTUs, RTUs and HMIs. So this enables seamless system integration and we also have some functional units of SCADA. So it consists of master terminal unit. So MTU is the core of the SCADA system. So it comprises a computer, a PLC and a network server that helps the MTU communication with the RTUs. So basically considering remote terminal unit, so it is being employed in the field sites. So each remote terminal unit is controlled with sensors and activators and it is used to collect information from these sensors and further it can send data to MTU. So the RTU has storage capacity facility. So the function of RTU is to store the data and it transmit it when the MTU commands. So modern RTUs use PLCs for direct data transfer and control. So next we'll be seeing about the functions of SCADA systems. So SCADA system is a collection of hardware and software components. So it allows manufacturing units to perform specific functions. So in SCADA systems, it integrates both hardware and software components. So as I told you before, it continuously monitors and it collects real-time data from industrial processes, and it provides operators with live insights through human-machine interfaces. So that facilitates the interaction with the field devices and control stations. So system events are automatically recorded here, and these recorded information will be stored in log files for traceability, and it is used for diagnostic purposes. So SCADA also supports virtual control of manufacturing operations. So these operations can allow remote supervision and adjustments. So in addition to that, it also ensures secure information storage, and it generates detailed reports to support analysis, decision making, and so on. So as we have discussed earlier, we have seen SCADA software which plays a significant role in the whole process analysis. So many manufacturing companies works with the SCADA software. So here many factories must be using software which is used for some specific reasons, and the lifetime of the software can also be considered here. So whenever you invest on software, it is always better to check if the software will last between 5 to 10 years down the lane, right? So whenever you go for request for information, so it is a business term used to specify details about vendors and suppliers. So even if you buy a software from a particular vendor, so they should be able to give you all the technical support when required. So there are so many types of so many types of software here. So we'll be seeing what are the types of softwares that can be used in SCADA systems. So the first type of software we call it as historian software. So this historian means the software should save the data with timestamps, and that can be used for future references. So your software should be proficient in handling all their logging information from the field data and so on. So when you consider SCADA technology, as we all know, technology is growing rapidly so fast to meet all our needs. So when you mean it as a technology, it should not imply that the latest technology that pop-ups in the market. So you should choose a technology that you can stay stable and you are secure for a longer time. Based on the alarm supervision and management, so SCADA systems are used. So it uses alarming features that comes along with the software development. So configuration of systems can be done. So the configuration of the alarm is very important here. And we can consider two types of alarm systems. So the two types, first type we call it as system defined alarms, so which is managed by the system itself, and it is considered to be user defined alarms which are managed by the user. And yes, we have some important functions where we can monitor and gather data in real time, and we can interact with the field devices, and we can record system events into a log file, and we can control the manufacturing process virtually, and we can do information storage and reports. So this is all about the functions of SCADA system. So next we'll be using about SCADA software. So in detail we'll see. what are the different types of software used in SCADA. So the first type is we see that is Cytec SCADA or Screenader's electric. So this type of software, which is very compatible and it is also flexible and it is very reliable in SCADA softwares. And this product was considered to be version 7.10, and it was released by Vigio Cytec. So this Cytec SCADA is still one of the most commonly used SCADA technologies, and this particular software can be a platform for SCADA developers, and it can actually become a part of SCADA alternatives for Wonderware. And next type of software, we call it as InTouch Wonderware. So here in this software, it has become one of the largest SCADA suppliers on the market. So comes from Wonderware, which is now owned by Schneider Electric. So although Wonderware is relatively new to the market, it is quickly gaining popularity. And this Wonderware system platform is a SCADA system with many plug-in and play, with many plug-and-play parts that are very modular, and it is considered to be very versatile. Because of this modularity of the scheme, we can readily customize requirements if you are choosing a particular SCADA software. So the benefit of this software is it uses open standards of communication, and it can cooperate with most PLC systems. So next type of software, we call it as Experience SCADA, Honeywell. So Honeywell is commonly used in PLC systems. So particularly they are using the software in US. So they are also a big player in the SCADA market, and it provides software platform for programming SCADA and HMI software systems. So we can use the software for a standalone SCADA scheme, or we can use it with Honeywell's PLC platform. So there are two types of platforms here. One is considered to be a C200 platform, and the other platform we call it as C300 platforms. And we'll be using along with RTUs like Control Edge RTU. So when you consider the software, although Honeywell's SCADA software is optimized to communicate with other Honeywell's products, we use PLCs and RTUs, and we still work when paired with non-Honeywell products. So that's the advantage of using this type of software. The other type is iFix General Electric. So this is an important software where it is considered to be the world's largest manufacturing businesses, and it also considered to be a significant player in the SCADA market. So iFix is one of their software solutions, and it is very flexible SCADA systems. So when you consider the advantage of using this iFix software, so the ability to develop screens quickly with HTML5 can be used, and the another reason we can consider is many drivers that can be allowed to set up networked and distributed systems. So it allows you to connect and exchange information with the most commonly used PLCs and other SCADA systems. So next we'll move on to ignition. So that we call it as inductive automation. So ignition is a SCADA scheme. So where they can use latest IoT architecture, and it is considered to be with full potential. So this induction automation is a very nice option where we can use the system up to date, and which is used along with Industry 4.0 norms and other techniques. So when you consider this software, it is very new to the SCADA industry, and how it is compared to some of the other systems. So between Ignition's IoT integrations and the fact they work along with the PLC systems. So that's the important usage of this particular software. And the other software will be learning about Cymatic WinCC V7 Siemens. So Siemens SCADA systems have been around for many years, and it is known as WinCC. So Siemens is one of the largest players in the PLCs and SCADA industries, and there are many businesses in the Siemens platform. So when you consider Siemens, Siemens is considered to be a huge company, and it has evolved with the PLCs and SCADA platforms, and it uses very modern technologies. So that's the advantage of Siemens. And now when you consider this SCADA industry, it gives many business confidence, and it makes us to trust with their SCADA applications. So that's all about SCADA software. So next I will move on to SCADA applications. So SCADA has become a more comprehensive, and we use so many features such as flexibility, reliability, scalability in automation or in automating complex systems. So when you consider SCADA applications, there are so many countless applications in the real world, and SCADA has already been used in surveillance, and it is used in control alternatives, energy production to agriculture systems, and so on. Because of the wide range of applications, it includes also chemical, gas, water communications, and power systems. So these are the applications of SCADA. And moving on to the next part, we'll be learning about the individual applications where we'll be using SCADA. Right, so here the application of SCADA, we have an example like water pump stations where we can use SCADA systems. So here all the environment should be considered. So it is around this. It is based on the surroundings, buildings, facilities, environments, and so on. So it facility managers uses SCADA to regulate cooperating with the other systems. So when you consider the role of SCADA system in water security, there are so many research which is continued nowadays, and it is performed on how to implement modern SCADA's concepts in water treatment plants, minimizing the risk of unauthorized network access. So, if you consider the risk here, cyber risk is an ongoing issue in the large enterprise. So, this has to be eradicated. So, the communication network of SCADA is distributed across the water distribution system, and we'll be using workstations typically with PC based, and it is situated at the treatment facility in the control room. So this enables the operators to view the entire process, and we can take control measures. Within the plant, we'll be using programmable logic controllers. For example, if you are using in chemical treatment and filters, we'll be using SCADA operations, where you'll be using remote terminal units. Uh, which is used in remote location, and it is generally found in sensitive fields. For example, if it is if it is a real-time scenario like pump stations, storage tanks, valve units, treatment centers, etc. So this RTU communicate with a wide area network, and this gives the radio scheme where we can specify significant benefit of SCADA schemes. Uh, and with a safety measure controlling all the activities. So these type of systems are connected to the surveillance systems, so that can either decrease the need for manned patrols considerably or we can eliminate them. So moving on to the other application like water treatment plant and SCADA applications. This SCADA scheme can provide ongoing surveillance of all places, unlike patrols. So you can easily interface security systems or any other appliances, including video cameras, motion detectors, contact switches, keypad, entry devices, and card readers. We'll be using SCADA systems where we can provide alarm management instances where many alarms will happen at the right time. These types of SCADA platforms are used, and we have seen one example of water pump stations. So next we have one more example. So here we are considering SCADA systems in thermal power plants. So many operational inspections of thermal power plant is automatic, and in this modern thermal power plants, most operational inspections are automated, and though we have some manual intervention, we still need a specific scenarios to support all these types of scenarios. Plants are equipped with robust monitoring and alarm systems. So these systems will notify operators when key parameters are deviated with the expected ranges. Uh, so Okay, so next we'll go with the demand. So when you consider the demand, as the demand for higher reliability and operational efficiency continues to rise, so there will be consistent inspection and real-time tracking, which has become more essential nowadays. So there are also manual measurements across different process stages, where we can introduce errors, underscoring the need for automation and so on. So by integrating programmable logic controllers, and we can achieve more efficient centralized supervision of the entire process. So this is about the thermal power plants and the applications of SCADA units. So next we'll be seeing an application of using SCADA systems in forestry, pulp, and paper industry. So the forestry, pulp, and paper industries also rely on SCADA systems. So here also everything has to be done with an automation process control. So whenever we use automation and process control for energy management, we drive control, power protection, enclosure systems, and safety. Everything has to be considered. And SCADA systems are very supportive, and it is used throughout the paper supply chain. So which includes wood yard, chippers, evaporators, digesters, refiners, cleaners, drying and pressing, and so on. Everything can be considered in SCADA systems. So this complex processing of trees into paper is automated from one end to the other by establishing SCADA systems. So here you will be learning about the difference between PLCs and SCADA. So the first difference you will be learning about the feature. So you have different types of feature in PLCs and SCADA. So basically I'll list some differences between PLCs and SCADA. So the first primary role is to execute control logic, and it manages real-time operations of machinery and processes. When you consider in SCADA, it monitors, visualizes, and supervisor processes across multiple PLCs and RTUs. So it's when you consider based on type, it is PLC is hardware-based controller, and SCADA is software-based system with integrated hardware and communication interfaces. So next, it's based on functionality. So here in PLCs, it can handle local high-speed control tasks, for examples like motor control, valve actuation, etc., and so on. And here in SCADA systems, it provides centralized monitoring, data logging, alarms, and operator interface. So next we'll move on to user interface. So typically we have programmed via engineering software. So no direct user interface is needed. So here in SCADA systems, it includes graphical HMIS for operator interaction and visualization. So here also we are going to see about some other differences like data handling. So in PLC system, it processes and responds to input output signals in real time, and in SCADA systems, it collects, stores and display data from multiple sources for analysis and reporting. So moving on to the scope, PLC systems are localized control for specific equipment as a subsystems, and when you consider SCADA here, so it uses system-wide supervision across multiple sites or units. So next, depending on programming language, so here in PLC we'll be using programming languages like ladder logic, structure, text, function block diagram, etc. and so on. And in um, um, SCADA architecture, we'll be using non-typically yeah, here we will be using non typically programmed, which relies on configuration and scripting for virtualization and alarms. So next we'll be seeing about the integration part. So in PLC systems, often it is embedded in field devices and control panels. And here, when you consider in SCADA systems, it runs on servers or workstations. So it connects PLCs, RTUs, and sensors. So you have learned about the basic differences between SCADA and PLCs, and in some cases both a little bit confuse each other. So here you have to understand what is PLC is programmable logic controller. So this controller is essentially rugged with a mini computer that sits on the field within a panel. So the PLC will monitor the state of these inputs. For example, we can say the speed of a monitor. So it depends on the program inside. So it considers some output variation to control these field devices. So for example, we can stop the motor. SCADA systems sit on top of programmable logic controllers. So PLCs are always part of SCADA network, and we can form an interface between the field and SCADA. So here we also use SCADA, and we are logging some information. So the data that is logged and stored in the SCADA system is typically occur through communication. So the PLC will continue to execute this program. So reading the inputs and writing the outputs and so on, everything is done here. And the SCADA system is used to keep a log of the historical state of these inputs and outputs. Where we can use all these information for data analysis and auditing. And we have programmable logic controllers. We have a limited capacity for long-term data storage. So although SCADA systems can be programmed to control, we use certain aspects to control the field, and it is usually in unwanted situations we'll be using PLCs that can run autonomously, and we'll be able to uh, we'll be able to program a certain condition where situation is difficult and where we encounter some issues. So due to this complexity of the real world, it is often not possible. So in this case, we'll be using operator input, which is required for correct functioning of the semi-autonomous system. So the level of control on the SCADA screen is given as HMI software. So this software operates or interacts with the um, uh, interacts, which is generally much less than the control execution of PLCs. We have seen some basic information and the differences between SCADA and PLC. So SCADA systems are primarily used for monitoring and data acquisition with control capabilities used under irregular or complex circumstances. So it should be noted that a SCADA system technically includes PLCs, while SCADA will communicate with PLCs also. So, for example, we can say conveyor belt has stopped, and our right outputs, for example, start conveyor belt. Depending on how it is programmed, everything has to be considered here. So, a PLC forms a part of SCADA network. So, asynchronously receiving and executing certain commands from SCADA, for example, like operator commands, it can stop the pump. Okay, so these type of examples can be considered, and it is used with SCADA network as a source of data. So, students, so I'll be ending this particular presentation now. So here in this unit 5, we'll be having two more topics. So that will be continuing in the next classes. So as of now, we have completed the fourth part of unit 5. So till two more topics are there. So we'll be seeing that topics as soon. Thank you, students.